So, use S1 equal to 110. Now, let's go to the spacing beyond the critical region. Or dito na tayo ngayon sa S2. For that, you have 4 conditions or 4 equations to get your required S2. First is 16 times diameter of bar, which is 16 times 25. It will give you 400. Next condition, 48 times diameter of tie, which gives you 480. And minimum of BH, so 450. And finally, 150 mm. Now, this is optional. So, bakit optional yan? Kailangan to sa seismic requirement, 150 mm. Ngayon, kung ayaw mo naman, tanggalin mo yan. So, ang mag-prevail dito sa tatlo, kung tatanggalin mo yung asterisk na yan, yung 400 mm. But, sa practice, laging ginagamit ko tong 150 mm. So, ang mag-govern dito, obviously, ay 150 mm. Ngayon, so ang ating S2, so your use S2 equal to 150. Okay, so review natin. Ang ating S1 is 110, ang ating S2 is 150. And then, what is this N? N is simply LO divided by S1 plus 1. N is the number of bars that you are going to put at the critical region sa taas tsaka sa baba. Ang ating detailing ngayon ay use 10 mm, ties spaced 1 at 50. Laging meron yan, ano? And then N at 110. And then rest at 150 mm towards mid-height. So, meron tayong example. Balik tayo sa problem 148. Nasa Roman numeral number 1. Investigation of tide column. Dito sa problem 148, we have a 600 by 600 square column. So, check clear spacing between rebars and find spacing of 10 mm ties. Ngayon, ang clear spacing between rebars is yan. Okay? So, S sub B is equal to 600 minus twice of clear cover minus twice of diameter of ties. Yang divided by 4 na yan, eto yun, apat na spaces, 1, 2, 3, 4. Spaces simply means the space between rebar. Okay, so divided by 4, you have 125 mm. Note na 125 mm is less than 150. So therefore, okay. Ngayon, saan nakuha yung condition na 150 mm na yan? When in fact, yung lecture natin kanina, 350. Okay? So, dito nang galing yun sa ating lecture 0 short column, dun sa last page. Yan. Okay, so, dito siya. Check clear spacing between column rebars. Your S sub B should not exceed 150 mm. And likewise, S sub B should be greater than the maximum among these 3 conditions. Ang ibig sabihin yan, para siguradong makapasok yung mga bato tsaka yung beam rebars. Okay, so 1.5 diameter of bar, 40 mm, then 4/3 diameter of aggregate. So, dito nang galing yan. Okay, so S sub B maximum of 1.5 diameter bar and 40 mm. So therefore, okay ang ating spacing of bars. Next is, we now check your H sub X. By the way, eto, spacing clear spacing between bars, ang kailangan mo dito, yung spacing, not necessarily for cross ties. Remember na, yung ating lecture kanina, yung 350, this is for cross ties, okay? Yan. And this 150 is not for cross ties. So, okay lang yan. Now, let's check your H sub X. This time, consider na natin yung 350. Take note na 350 is for cross ties. So, HX, since this is a square column, your HX1 is the same as HX2. Let's say, maglalagay tayo ngayon ng cross ties dito sa gitna-gitna lang. Obviously, ayaw nating maglagay ng maraming cross ties, di ba? Iiwasan natin yung ganyan. Dalawang cross ties. Ayaw natin yan kasi magastos. At lalong-lalo na ayaw din nating maglagay ng closed ties. Ganyan. Okay? So, as much as possible, ilimit natin sa single-single na cross ties. So, this is now our figure. So, obviously, ang ating HX would be center to center nung. So, our HX now would be 600 minus twice of clear cover, minus twice of ties, minus diameter of bar, all over 2. All over 2 dahil dalawang spaces lang in between ties and cross ties. Okay? Remember, ties and cross ties. Pero in between rebar, obviously you have 4 spaces. But between ties or cross ties, you have 2 spaces. That's why it is over 2. Plus 32 and 10, you now have 276. So less than 350. Therefore, okay yung cross ties natin na isa. Now, we compute your S sub X. S sub X is this equation. Saan galing yan? Dito. Okay? Remember this equation. So, your spacing X is 124.67. Now, you have 3 conditions for your S1. Remember this. Okay? So, minimum of BH all over 4. Since B is equal to H, so that is simply 600 divided by 4. And then 6 diameter of bar. And finally, your S sub X. So, ang minimum dito sa tatlo is simply your S sub X. But you cannot use 124. You have to round down. Kaya, 120 ang gagamitin natin. Okay? Now, let's take another example. Meron tayong column dito na measuring 470 by 1140 mm. Tapos, meron siyang unsupported length na 3.2 meters. And then, rebars, 14 pieces, 32 mm. Kaya ang gagamitin natin ay 12 mm na ties. And then, clear cover is 40 mm. So, first step is to measure your HX in the short and long direction with reference to your corner bars only. Okay? Or no cross ties. So, ang HX1 natin ay 378. HX2 is 1048 mm. Note na HX2 is, ayan. And then, let's check for cross tie requirements. Remember na kapag less than 350 or equal to 350, hindi mo kailangan ng cross ties. But obviously, these 2 HX are greater than 350. So, you need cross ties. So, 378 divided by 350 is 1.08. Okay, so round down, magiging isang pirasong cross tie. So, magiging ganyan yan. Next is, yung 1048 divided by 350, this is 2.99. So, round down din ito. So, say 2 ties. So, magiging something like that. Okay? Next is, ayan ang kinalabasan nitong 1 cross tie tsaka 2 cross ties. Okay? So, sa isang cross tie, you have 2 spaces. 1 space, second space. Dito naman sa dalawang cross ties na dinagdag natin, you have 3 spaces. So, 1, second, and third space. Now, let's check the HX with cross ties. So, ang ating HX ngayon is, ito, HX1 is 470 minus 2 times the quantity 40 plus 12 minus rebar diameter divided by 2. Dahil meron tayong 2 spaces. Okay? Plus 32 plus 12 will give you 211. Then sa HX2 naman, dito, you have 3 spaces, kaya divided by 3. So, 378.11. Take note na ito ay still greater than 350. So, you might probably want to add another cross tie. As per our previous lecture, sa pag-compute ng SX, kukunin natin yung maximum na HX, di ba? So, 378. Anyway, in this example, kinompute natin yung SX using both values. So, dito, 211. Take note na itong HX1 is less than 350. Okay? So, yung SX dito is nasa range. Okay? 146 is greater than 100 and less than 150. So, therefore, okay. Next, remember na maximum ang kukunin natin dito. So, let's try 378. But remember na this is greater than 350. So, since this is greater than 350, kailangan nating magdagdag ng cross tie. So, dapat magiging 3 yan. So, let's check here. So, computation ng SX using 378.11 will give you 90.4, which is less than 100. Okay, so hindi na-satisfy yung ganitong condition. Okay? So, yung condition na yan, ito siya. So, dapat increase short cross ties. So, magiging 3 na dapat yan. Okay? Next is, let's try this one. Assuming ang gagamitin natin ay 2 cross ties. So, your SX here would be 90.44. This time, pinili na natin yung maximum among the 2. So, SX is 90.44. Note that the range should be like this. 100 is less than your SX and SX is less than 100 is less than SX, SX is less than 150. Yan. Now, since 90.44 hindi nasunod yung ating condition. Kaya, ang gagamitin natin ay yung minimum range na 100. So, use SX is equal to 100. Now, let's proceed to computing your critical region. So, ito yung equation ng critical region. Maximum of BNH, LU all over 6, and your 450. Okay, so the maximum among these 3 is 1140. So, ito ang ating critical region. Next, compute the required spacing at critical region. So minimum of BH all over 4, 6 times dB, and your SX na 100. Okay? Not this one. So, the minimum among these three is 100. So, yan ang gagamitin natin na S1. Next, the number of ties at critical region. The number of ties is LO divided by S1 plus 1. So, this is 12.4. So, round up mo palagi yan, magiging 13 pieces. So, ito na ang spacing naman beyond LO, or ito yung nasa mid-span or mid-height. So, required S2 is the minimum among 4 conditions. 16 dB, 48 diameter of tie, minimum of the dimensions, and 150 mm. So, by seismic requirement, ito ang sinasali natin ito. Sinasali ko ito sa practice. So, ang mag-govern dyan is 150 mm. Okay?